Today we're going to take what we've learned about inequalities so far and apply it to compound inequalities. Compound inequalities generally fall into the category of or and. Let's talk about compound or inequalities first. A compound inequality is a sentence with two statements joined by the terms and or or. Or inequalities represent the union of the solutions of two inequalities. Plotting a compound inequality is no different than plotting any inequality. You're just doing it twice. So the first step is going to be solve the first inequality. I have negative 6x is less than or equal to negative 18. What's happened in my variable? I'm multiplying by negative 6, so I'm going to divide both sides by negative 6. That's going to give me on the left, x is less than or equal to positive 3. Now notice something happened there. I read less than or equal to from the original inequality, but the actual answer is greater than or equal to. That's because we divided by a negative. Whenever you multiply or divide by a negative in an inequality, it automatically flips around that inequality symbol. So we went from less than or equal to greater than or equal to. Now that I've solved my first inequality, I'm going to plot the first inequality. It's going to be a closed point at positive 3. Now I need to figure out which direction my arrow is going to point. So I'm going to pick a value, let's say 0. 0 is great because it's greater than all negatives. It's less than all positives. 0 is not greater than or equal to 0 or to 3. So I'm not going to point at 0. I'm going to point away from 0. If I get a false statement, I point away from the point or value that I substituted in. If I get a true statement, I point at that value. Now I'm going to solve the second inequality. This is a two-step inequality, so it helps to know which operations are present and the order that they're presented in. To solve a two-step equation or inequality, you can always use the arrow method or work through it logically. I'm multiplying by 2 and adding 4, so I need to go in the inverse direction with inverse operations. I'm going to subtract 4 and then divide by 2. So I'm going to subtract 4 from both sides. That'll give me negative 9 on the left and just 2x on the right, because 4 minus 4 gives us our identity of 0. Now I'm going to divide both sides by 2. Be careful, negative 9 divided by positive 2 does not flip the inequality. It's only when I'm dividing or multiplying by a negative. I can divide a negative by a positive and it does not affect the inequality. So that gives me negative 4.5 is greater than x. Now I need to plot this. It's going to be an open value or open point. Whenever I have a decimal, I need to figure out which two values or which two integers my value is located between. Negative 4.5 is between negative 5 and negative 4. 0.5 is exactly half, so I'm going to put it exactly halfway between negative 4 and negative 5. Now I need to figure out which direction that arrow is going to point. So I can pick a value and substitute it in for x. 0 is a great value. Negative 4.5 is greater than 0. That's a false statement. I know that because 0 is to the right of negative 4.5, so that means negative 4.5 is less than 0. So I'm going to go to the left. I also know that all negatives are less than 0, so there's no negative that can be greater than 0. If I get a false statement, I point away from the value. If I get a true statement, I point at the value that I checked. Generally speaking, or inequalities point away. This isn't always the case, but generally speaking it is. All the values to the left and all the values to the right represent our solutions. We have solutions to our first inequality to the right, or we have solutions to our second inequality to the left. With an or compound inequality, you do not have to have one set of solutions that works for both inequalities. Let's try one together. I'm going to start by solving this first inequality. It's a two-stepper, so I'm going to write out my steps. I'm multiplying by 10 and subtracting 3. To undo that, I'm going to add 3 to both sides and then divide by 10. When I add 3 to both sides, negative 3 plus 3 gives me an identity of 0, so I'm left with 10x is greater than 57 plus 3 is 60. Next, I said I'm going to divide both sides by 10. 10x divided by 10 gives me just x. 60 divided by 10 gives me 6. The inequality does not flip around since I did not multiply or divide by a negative. At this point, it's no different than solving a two-step equation. I'm going to plot my value. I need to put an open point at 6. It's open because it's just greater than, not greater than or equal to. To figure out which way my solutions are located or which way to point my arrow, I'm going to substitute in a value. 0 is a great value to check. Is 0 greater than 6? No. 0 is less than all positives, greater than all negatives. I got a false statement, so I'm not going to point at 0. I'm going to point away from 0. I have half of my compound inequality graphed, so now I'm going to start in by solving my second inequality in the compound inequality statement. It's a two-stepper, so I'm going to take the time to figure out what's happening to the variable and then how to undo that. Order of operation tells me I'm multiplying by 2 and adding 3. Notice that it's addition of 3 because it's positive 3. The plus sign in front of 2x describes what the 2x is doing, not what the 3 is doing. This is of little consequence here, but if there was a negative involved, if it was 3 minus 2x or negative 3 plus 2x, errors are often made. If that lead value that's by itself separated by addition is positive, we're adding. If it was negative, we're subtracting. So I am undoing those operations by subtracting 3 and dividing by 2. I'm going to subtract 3 from both sides. 3 minus 3 gives me 0, the identity for addition subtraction, leaving me with just 2x is less than or equal to 4, because 7 minus 3 is 4. Next thing I said I'm going to do, next operation is division. I'm going to divide both sides by 2. 2x divided by 2 gives me 1x, because 1 is my identity for multiplication division. 4 divided by 2 gives me 2. So the inequality simplifies down to, or solves down to, x is less than or equal to 2. So that's going to be a closed point at positive 2. I need to figure out which direction it's going to go. I'm going to substitute in a value. 0 is less than 2. Which means the statement 0 is less than or equal to 2 is a true statement. So I'm going to point at 0, which is to the left. If I get a true statement, I point at the value I substituted in. If I get a false statement, I point away. Notice that I've shown where all the solutions are located to both of these inequalities. All the solutions to my first inequality are to the right of the open point at 6. All the solutions to the second inequality start at positive 2 and go all the way to the left. On your own, try solving and graphing this compound OR inequality.